This is Jacob's Algebra, Chapter 10, Lesson 4. This lesson is all about factoring. How do you factor second-degree polynomials? Remember, a second-degree polynomial is a polynomial where the highest power term is squared. So let's start with an expression. What if we have x squared plus 9x plus 20? How could we factor that? There aren't any common terms. If you try and look for the greatest common factor here, that would be 1, because there is no other factor in common between all of these terms. But this expression can still be factored. I'm going to show you two different ways to do this. What we're going to do is multiply two binomials. We're going to start off with an x times an x because x times x will give us x squared. And then what we need for the rest of these, we need two numbers that when multiplied will give us 20, but when added will give us 9. So what would those numbers be? Well, what we need to do is start off by listing for 20, what are all the possible factor pairs? We could do 1 times 20, we could do 2 times 10, or we could do 4 times 5. That's all the possible factor pairs. Now we need to see which of these factor pairs will add to 9. Well, 1 plus 20 is 21, so that won't work. 2 plus 10 is 12, so that won't work. But 4 plus 5 is 9, so that one will work. So we'll put in plus 4 and plus 5. It doesn't matter which term we chose to write in first. We could have written plus 5 in the first parentheses and plus 4 in the second parentheses. And so this is how we can write x squared plus 9x plus 20 in factored form. Another way that we can do this is with our grid method. So I'm going to draw our grid and put in our grid lines. Okay, now with our grid method, we know that in this top left box, we're going to have our x squared term that we start with. And in the bottom right box, we're going to have our last term, 20. And we know that these two boxes here, when we add those two boxes together, we need to get 9x. Okay, so what do we have to do to get x squared? To get x squared, we need to multiply x by x. To get the 20, what are the possible ways that we could make 20 by multiplying two numbers? Well, we have 1 times 20, 2 times 10, and 4 times 5. Whatever those two numbers are, they have to add to 9. So that means we're going to use the 4 and the 5. So I'm going to put the 4 here, and I'm going to put the 5 here. 4 times x is 4x. 5 times x is 5x. And when you add 4x and 5x, you get 9x. So writing out x squared plus 9x plus 20 in factored form would be x plus 4 times x plus 5. So that's two different ways that you can look at trying to solve this problem. The box method is the easiest to see because once you put everything into the box, you can tell immediately whether you've actually done it right or not. Okay, so let's start working some example problems. Number 4 is just like number 11 that I assigned for homework. We're going to work just two parts from here. Part C is x plus 3 times x minus 5. Now, we know two different methods for working out products like this. We can straight out multiply them, or we can use the grid method. I'm going to do both for this one. First, I'm going to multiply. I'm going to multiply x by everything in the second parentheses. X times x is x squared. X times negative 5 is negative 5x. Now we go with the second term here. 3 times x is 3x. 3 times negative 5 is negative 15. I knew that this 3x needed to be positive because my 3 was positive and my x was positive. So the product had to be positive also. So we have like terms here, negative 5x and positive 3x. So what we end up with here is x squared minus 2x minus 15. We can also do this by the grid method. So let me draw my grid here. Okay, so we have x plus 3 and we have x minus 5. First box is x times x, that's x squared. The second box is 3 times x, which is 3x. The third box is negative 5 times x, which is negative 5x. And the final box is negative 5 times 3, which is negative 15. And again, you can see that we end up with x squared minus 2x minus 15, because 3x minus the 5x is going to give us our negative 2x. Okay, we're going to work just one more part from number 4 because y'all have done a lot of this type of multiplication before. This one is x minus 3 times x minus 5. And I'm just going to do this straight out multiplying. I'm going to multiply my first term in the first parentheses by the entire second parentheses. X times x is x squared. X times negative 5 is negative 5x. Now I'm going to multiply the second term in the first parentheses by everything in the second parentheses. Negative 3 times x is negative 3x. Negative 3 times negative 5 is a positive 15, because negative times negative will give us a positive. We have like terms here, negative 5x and negative 3x. So I can write this as x squared minus 8x, because negative 5 and negative 3 makes negative 8, plus 15. So this is how you're going to work the parts in number 4, which is just like number 11 that I assigned for homework. Really not too difficult. You've done a lot of this already. Okay, number 5 is a little bit different. Number 5 is a little bit different, as I said, because they go ahead and supply you with a worked out grid. So if you look at part A, you see this grid already worked out for you. And it says, express the area of each of the following figures, both as a polynomial in simplest form and as the product of two polynomials. That doesn't sound like English. So what they're actually telling you to do is to take your grid that you've drawn, or actually that's provided for you, and make it look like math. So what we're doing here, what this grid shows, is x plus 2, which is what we have at the top here, times x plus 6, which is what we have on the side. And when we multiply those together, we get x squared plus 2x plus 6x makes 8x plus 12. This is what they're asking you to write out. It doesn't really quite sound like it from what the problem says, but express the area of each of the following figures as both as a polynomial in simplest form. This is the polynomial in simplest form. And as the product of two polynomials. This is the product of two polynomials. This is what the problem is actually asking you to do. There's very little actual math involved in doing this problem because they already provide you with the grid, and the grid is completely filled in. What they're wanting you to do is to take the grid and translate it into math. So this is number 5, which is just like number 12 that I assigned for homework. They're going to provide you with the grid already filled in, and all you have to do is write down in regular math terms what that grid is showing. This grid is showing x plus 2 times x plus 6, and that it equals x squared plus 8x plus 12. Okay, so the next problem we're going to look at is number 6. Number 6 says one of the steps in factoring a second-degree polynomial into a product of two first-degree polynomials is to factor its constant term into the product of two numbers whose sum is a given number. Factor each of the following numbers into the product of two numbers having the indicated sum. Okay, what they're doing is they're saying, we're going to tell you what the product of two numbers is and what the sum of those same two numbers is. You have to tell us what the two numbers are. So for this one, I'm going to write product, and I'm going to write sum, and I'm going to draw a nice straight line in between them. Okay, so I'm going to write down a product of 10 and a sum of 7. What two numbers will have a product of 10 but have a sum of 7? Well, the only ways that we can make 10 as a product are 1 times 10 and 2 times 5. So which of those pairs has a sum of 7? Well, the 2 and the 5. So our two numbers are 2 and 5. Okay, what if our product is 10, but our sum is negative 7? How's that going to work? Well, still to make 10, we need 2 and 5, but if we have a negative 2 and a negative 5, negative 2 times negative 5 will still give us a positive 10 because negative times negative is a negative. And since both of these numbers are negative, when we add them together, we will definitely get a negative. -2 plus a -5 is a -7. Okay, what if our product is -33? Okay, ignore the sign for the moment and just look at the number that we need to get. We need to get 33. What are the possible factor pairs that we can use to get 33? Well, 1 times 33 or 3 times 11. Those are the only factor pairs that we can use to make 33. Now, because the product is negative, that lets us know that one of these numbers is negative. In each factor pair, one of the numbers is going to be negative. We don't know which yet. Well, we know that the product is -33, but the sum is 8. So if we need two numbers of opposite sign, when we add them together to get a positive sum, it means that the bigger number has to be the positive one. To get a negative sum, the bigger number has to be the negative one. Okay, we have a positive sum here. So what that means is we need to find the difference between the two numbers in the factor pair, and that difference needs to be 8. And then we will make the bigger number our positive number and the smaller one our negative number. The difference between 33 and 1 is 32, so that won't work. The difference between 11 and 3 is 8, so that will work. And we know that 11 has to be our positive number and 3 has to be our negative number, because 11 plus a -3 will give us a positive 8. If we swapped the signs, then we would end up with a -8, which leads us to the next problem, which is a product of -33 and a sum of -8. To get a sum of -8, we would need a negative 11 and a positive 3. So looking at number 6, they're going to give you a number that is the product and a number that is the sum. And you have to figure out what two numbers, when multiplied together, will have that product, and when added together will have that sum. If your product is positive, then either both numbers are positive or both numbers are negative. If your product is negative, then one of them has to be positive and the other one has to be negative. If your sum is positive with a negative product, then the bigger number has to be positive. If your sum is negative with a negative product, then the bigger number has to be negative. So that was number 6, which is just like number 13 that I assigned for homework. So now let's take a look at number 7. Number 7 is a fill in the blank. Tell what polynomial should replace the blank in each of the following equations to make it true. Okay, so I have put up a page that shows the first 4 parts for number 7. So part A, they give you x squared plus 11x plus 18 equals x plus 2 times something. And we have to figure out that something. Well, we can figure out the first term that goes in here pretty easily, because to get an x squared for our first term, we have to multiply x by x. So we know that has to be an x. The question comes, what goes right here? Whatever goes right here, when we multiply it by this positive 2, we have to get 18. When we add it to the positive 2, we need to get 11. So what can we multiply by 2 to get 18? Well, 2 times a positive 9 will give us 18. And 2 plus a 9 will give us 11. So the x plus 2 times x plus 9 will give us x squared plus 11x plus 18. Now we look at part B. The equation we're given is x squared minus 9x plus 20, and they started us off with x minus 5. Now to get an x squared, we know we have to multiply our x by an x. But what else goes over here? Well, we know that we need to end up with a positive 20. We have to multiply something by -5 to get a positive 20. Well, that would have to be a -4, because we have to have two negatives to multiply together to make a positive. And then we check to make sure that -5 plus -4 adds to -9, and they do, which is our middle term. So that's how we factor x squared minus 9x plus 20. Okay, part C is x squared plus 6x minus 7, and they provided us with the second parentheses this time, x minus 1. Well, we still know that to get this x squared, we have to multiply this x by another x. Now, our last term, -7, We have to get that -7 by multiplying -1 by something. To get